Mercedes has been under the microscope since the moment the 2026 season began. The compression ratio loophole, the energy deployment advantage, the customer team information dispute. Each controversy generated headlines, paddock tension, and eventually some form of regulatory response. Now, there is a fourth, and this one is different because it involves something every single spectator can see with their own eyes on television. The 1.7's front wing does not always close at the same speed. At some corners, it snaps shut instantly. At others, it closes slowly, progressively, over a period that video analysis suggests could be approaching 800 milliseconds. The legal limit is 400 milliseconds. The FIA is now examining whether what Mercedes have built is an ingenious piece of engineering or a system that has been operating outside the permitted limits since the season began. To understand the controversy, you need to understand what the 2026 active aerodynamic system actually does. Formula One replaced DRS with a fully integrated active aero system for this season. Cars now operate between two defined states: Z mode for cornering, where the wings close to generate maximum downforce, and X mode for straights, where the wings open to reduce drag and maximize top speed. Both the front and rear wings can move between these two positions. The regulations allow this movement freely, but they control exactly how quickly it must happen. The FIA's technical regulations state that the maximum transition time between the two fixed positions must not exceed 400 milliseconds. That limit exists for a specific reason. A wing that transitions faster gains more downforce sooner on corner entry. A wing that transitions more slowly stays in low drag configuration for longer into the braking zone, maintaining higher straight line speed slightly deeper before finally closing. If a team could vary that closing speed depending on the corner type, it would represent a significant aerodynamic advantage. Faster closure at tight, slow corners for immediate grip. Slower closure at high-speed braking zones to carry maximum speed further into the stop. That is precisely what the 1.7 appears to be doing, and that is precisely what the FIA is now examining. The story began not with a formal protest or an official inquiry, but with a social media post. The account at DRS Unlocked published a slow-motion analysis of the 1.7's front-wing behavior across different corners at the Chinese Grand Prix. The footage, slowed to 4 times below real speed, showed something that appeared to be operating outside normal parameters. At Shanghai's Turn 9, a shorter, faster braking zone, the front wing flap closed rapidly, snapping back to the high downforce position almost immediately. At Turn 14, Shanghai's long, heavy braking zone, where cars decelerate from over 300 km/h to approximately 90, the same wing closed significantly more slowly. The transition at its slowest appeared to take approximately 800 milliseconds. That is twice the legal limit of 400 milliseconds. The immediate response from engineers across the paddock was not dismissal. It was attention. It was attention. Because if the video analysis was accurate, it described a system that was delivering exactly the kind of corner-by-corner balance optimization that every aerodynamicist on the grid has been trying to achieve since the 2026 regulations were written. Formula Tecnica, one of the most technically rigorous Italian Formula One publications, published a detailed analysis confirming that the FIA has taken time to examine the situation more closely. Their conclusion was specific. The legality of this system is currently in the balance, and the governing body has not yet issued a formal ruling on the transition timing measurements. The technical analysis published by Formula Tecnica explains the engineering logic behind what Mercedes appear to have developed with precision. When a car brakes heavily from high speed, the aerodynamic balance shifts dramatically toward the front of the car. The rear loses downforce as the wing opens. And if both the front and rear wings open and close at the same rate, that balance shift becomes unpredictable and unsettling for the driver. This is exactly the problem Ferrari encountered with the Macarena wing in China. The rear wing rotated at a different rate to the front, creating an aerodynamic imbalance through the transition phase. Hamilton spun at Turn 6 when the wing closed unexpectedly into a braking zone. Mercedes appear to have solved this problem by designing their front wing to close at different rates depending on the corner type. At Turn 14 in Shanghai, the long high-speed braking zone, the front flap closes slowly, allowing the aerodynamic balance to migrate progressively from rear to front throughout the braking phase, rather than shifting abruptly. This gives the driver greater stability and confidence through the most demanding deceleration zones on the circuit. At shorter braking zones like turn 9, where the driver needs immediate front-end grip and committed turn-in, the same flap closes faster, shifting the balance forward more quickly to support the rotation. Whether this modulation is achieved actively through GPS-triggered software or passively through the aerodynamic load resistance, the flap must overcome at different speeds remains an open. But the outcome is identical, a front wing that behaves differently at different corners, optimizing balance in a way no other car on the grid appears to replicate. The FIA's position on this issue is technically complicated. The 2026 active aero regulations were written with transparency in mind. Every car's wing actuators are connected to position sensors that feed real-time data directly into the FIA standard ECU. In theory, if the 17's front wing is taking 800 milliseconds to close on track, the FIA's own telemetry should be recording that number in real time and flagging it automatically. That is the strongest argument that Mercedes are not cheating. If the system were genuinely breaching the 400 millisecond limit, the FIA's own data would have already shown it. The fact that no disqualification or formal ruling has been issued suggests either that the sensor data does not confirm the video analysis or that the governing body is still working through the technical interpretation of what the data shows. But there is a more nuanced possibility. The regulations define the maximum transition time between the two fixed positions. If Mercedes have engineered a system where the actuator completes its movement within 400 milliseconds, but aerodynamic loads acting on the carbon fiber structure cause the wing to physically settle more slowly afterward, the actuator would be legal, while the wing's visible behavior on camera would suggest otherwise. That is the gray area the FIA is now navigating. It is not a simple yes or no. It is a question about what the regulation actually measures, what the sensors actually record, and whether the physical behavior of the wing in high-speed conditions is captured by the data that the rules require teams to provide. The consequences of a negative FIA ruling would be severe and far-reaching. A car found to be using an illegal aerodynamic system is subject to disqualification from the races in which that system was used. If the 17's front wing has been operating outside the permitted transition time since Australia, that potentially means 3 race results. Melbourne, the China Sprint, and the Chinese Grand Prix could be subject to retrospective review. Russell won Australia. Antonelli won China. The championship points those results generated would be at risk. Mercedes leads the constructors' standings. Russell leads the drivers. A retrospective disqualification at this stage would not just alter the results. It would fundamentally reshape the entire 2026 championship narrative before the season has reached its 4th round. But that outcome remains conditional on the FIA's technical determination being clear and unambiguous, which, given the complexity of the actuator versus aerodynamic load question, is far from certain. The more likely immediate outcome is a technical directive clarifying how the transition time must be measured and under what conditions. That would force Mercedes to modify the system going forward while leaving the existing results intact. Whatever the resolution, one thing is clear. This is the 4th major regulatory controversy surrounding Mercedes in a season that is 3 races old. The compression ratio loophole, the customer team information dispute, the ADUO timing debate, and now the front wing. At some point, the accumulation of gray areas stops looking like coincidence and starts looking like a philosophy. The FIA has taken time to examine this. Mercedes has not commented. No team has filed a formal protest. And the cars are about to line up on the grid in Japan. Having nevers is 3 to come to. With the 17's front wing operating exactly as it has been operating since Australia, Suzuka will produce more footage, more corner comparisons, more data for the engineers watching from rival garages, and it will make the question louder without answering it. Because the answer, whether this is genius or a breach, lives in the sensor data that only the FIA and Mercedes can fully see. Subscribe to Phone Perspective. We will be watching every corner.